Hello, welcome back to my channel Sen Tutorials. Today I'm going to start off with class 10 topic on circles. NCERT syllabus, NBSE syllabus, they're all the same. So we'll be starting off with this chapter of class 10, that is of course in mathematics, that is circles. Okay, so of course please do not forget to hit the like button if you like this video. Later on, of course, you don't like the button without even watching the video once. First finish up the video, and then of course please do subscribe to my channel if you like the videos, if you think that it will be helpful for you, so that you will get regular notifications on any new video that is being uploaded. Many more new videos will be uploaded on different classes, on different topics of mathematics as well as physics. Okay, then let me just go back straight to the point. That is class 10 mathematics chapter named circles. Now this is not going to be a very new topic, isn't it, that we have seen, like circles. So we have studied from our lower classes 6, 7, 8, 9 and all. In class 9 actually we have done a lot of circles. We have done lots of properties based on circles. So we're just going to do a little bit more again here in class 10 also. It's not going to be a difficult topic, okay? It's a very interesting topic. But here what I want you to do is please get your pen, your paper, your scale, your pencil, your rubber, and your rough book, of course, rough book, and then get it ready before we really begin. So as I spend some time talking with you, please get those pen, paper, pencil, everything ready on the table, because we will try to learn this chapter about its theorems, its properties, this time with a small twist. That is, we will try to learn it with activity method. So I want you to be actively involved. I want you to do the activities, because the theorems that we come across in geometry portions and all, every time what happens, like we memorize the theorems, most of us, not all, but only those students who try to go through the theorems by actively participating in the theorems, by doing some activities, that remains in our brain, isn't it? That remains in our brain, and then we don't have to really memorize it because we did that activity, right? So let's try to do some of the theorems here with activities. So for that I'll need your pen or paper or pencil, and your rough book, and your scale, and rubbers, erasers, and everything, your geometry boxes and all. Okay, so I hope you're ready with that. Now let's begin. Without too much talk, let's begin with circles. Now before we really go to circles, like the question is like, what is a circle? This is not a uncommon figure that you may have never seen, isn't it? We know lots of things about circles. So before really jump into circles, let's just try to connect all the small dimensions, all the small properties, and all the small things that we know about circles. And before we really start connecting, first thing is, what is a circle? We need to know what is a circle, isn't it? So most of the times what happens is like, okay, what is a circle? Yeah, we know what is a circle. Yeah, pata hai, But what is a circle? If somebody asks, then like the question is like, okay, circle kya tha? What is a circle, isn't it? So, alright. It's a very simple definition, no? Circle, what is a circle? A circle is actually a path, okay? The path, the path, rasta. The path traced, okay? The path traced by a moving point, no? The path traced by a moving point. There are some conditions. That condition is such that the path traced out by a moving point, such that its distance from a fixed point remains constant. So from a fixed point, you fix a distance and let the path move. That's just like tying a cow for grazing. So what happens is, if you tie a cow on one end, that point is called the fixed point. So what happens is, so that why do we tie a cow in the field? So that it doesn't wander around, isn't it? Within that same area only the cow will be grazing, right? So that point is called as a fixed point. So suppose here, if we assume this to be the fixed point, and then maybe like this is the fixed distance, let's say P, which is supposed to be 5 centimeter. So let the point move now, but the condition is fixed point, no changing. Fixed distance, no changing, 5 centimeters. So let the point move. What happens? Okay, that means if the point goes here, this 5 centimeter. The point goes here, 5 centimeters. So if it goes on moving, what happens is, it will trace a circle. The path that it will be able to move, it will trace, will be in this form. That is, it will trace out the figure which we call a circle. Okay, so that is what is called as a circle. Now some of the common things that we know about circles, that is, what is this fixed point called? I hope you're noting it down. Please make sure that you note down as a comment. Of course, this fixed point is called the center, right? The fixed point, of course, is called the center, isn't it? Right. The fixed point, of course, will be called as the center. And okay, just a moment, I have to check something. The fixed point, of course, will be called as the center. The fixed point, actually I was confused with the spelling of center. Now sometimes all these small things get really confusing, so I wanted to make sure that the spelling is really correct. No? Otherwise immediately you will press on the dislike button, isn't it? Okay. Centered, and this fixed distance of course will be called as the radius, as we all know it, right? So the center, the fixed distance as the radius, and the length of the path that is being traced. Suppose you start from here, and that length you move. Okay, this is like total length is 100 meters. So this length of the path that is being traced, what do we call this? We call this as the circumference of a circle. Then we have area and all, but we're not going to go into that mensuration part. No, we're just more interested in the geometrical aspect only here. Okay. Then of course, then okay, we have the radius. Then of course, we have a common term which we call chord. Which we call chord. What is a chord? A chord is actually like a straight line that passes through a circle, isn't it? A straight line that passes through a circle, or the many definitions, a straight line that touches two ends of a circle or the circumference of a circle. So a chord, let's say a straight line that passes through a circle, touching at 2 points on the circumference of the circle. So there can be millions of chords that I can draw. Here you can see now, touching at 2 points, this is one chord, this is one chord. We can have so many chords, we can just go on drawing and drawing. We can have, these are all known as chords. Okay, but there is one special chord. There is one special chord in a circle, that is what? This chord that passes through the center. Or any chord that passes through the center, what does it become? Any chord that passes through the center, that chord is the longest chord in a circle, which is also called as the diameter. So it becomes like double of the radius. So diameter is actually double of the radius, right? So these are some facts which we already know. Shall I rub it off? Okay. So these are called as some known facts that we already know about circles. So diameter done. Then of course there's another fact that is like about chords. No, for example, I just rub this off. About chords, what happens is actually a chord actually divides a circle into two segments, two parts, segments or two parts. The bigger part is called the major segment, the smaller part, this part. The smaller part is called the minor segment. Isn't it? But you are going to learn more about this in mensuration. No? So as I say, I'm not going to go too much into that mensuration part. This will be just an introduction, the basic terms of circles. Let's just get accustomed to it. Alright. But this special chord, the special chord which I was talking about, the diameter, isn't it? The special chord, actually what happens, what is that chord? What is that special chord which divides a circle into two parts? Semicircles, semicircles, half circle, that is the diameter, which is the longest chord, okay? So chord actually divides a circle always into two parts, two segments, major and minor segments. And this special chord that I always talk about, that is the chord that is the longest chord in a circle, actually divides a circle into exactly two halves or two semicircles. Okay, so these are some known facts. Now again, be patient. We're definitely going to go to the class 10 syllabus, but let's build up here. Let's try to connect all the small missing link. Let's go back to class 9 and see and try to recall what are the other properties that some of the properties that we learned about circles, class 9. One of the more common property that we generally learned was like chords. If you have two chords which are equidistant from the center, then of course those two chords were said to be equal in length, right? That was one of the theorems. Another one was like two equal chords. Of course, if these are two equal chords, then two equal chords will subtend equal angles at the center. And another, the other theorem, there were other theorems. The other theorems were like, okay, if I draw a chord, the moment when I draw a chord, I divide the circle into two segments. Angles in the same segment of a circle are equal. That is major segment, minor segment. So major segment, I draw. This is one angle formed by the chord. This is one angle formed by the chord. These two angles will be always same. So that means if this is 60, this is also going to be 60 degree. Same here also. In the minor segment also, maybe this is one of the angle. This is one angle formed by the chord. This angle, this angle. These two angles again will be same. So angles formed by a chord in the same segment, of course, are equal. Right? This is one. And then, of course, another one was like that special chord, again, the diameter, cuts a circle into two parts, semicircles, and then what happens is angle in a semicircle will always be 90 degree. That is, if this is one angle, 90. Here also 90. Same side, this also, no? So angle formed by a chord in a semicircle, of course, will always be 90 degrees. So these were some of the theorems that we learned. There was another one, right? Angles about like segments. This angle is equal to double of the angle at this angle is equal to double of the angle formed at the center. So all this we learned in class 9, right? So I hope that those memories are still fresh with you. If not, then grab a book of class 9 and then just go through the theorems, because these are all built up to the next class, no? So now this is class 10, so you will not be reminded of all these theorems. You will be expected that you know these theorems, okay? So make sure that you go through those theorems if you really want to learn. Now, here in this topic, what we are going to study in class 10 will be about tangents. Tangents. We're going to be studying about tangents. Those who have studied trigonometry, you may already know about this, like tangent and all, but what exactly is a tangent? What exactly is a tangent? I'll tell you, I'll keep it very simple, okay, in layman's language, okay? Let's not talk of so like mathematical terms and big definitions and all. I'll keep it very simple. What is a tangent? Tangent is nothing but a straight line that passes through a circle. No, straight line. Tangent, a straight line passes through a circle. Condition, touches at only one point on the circle, on the circumference of the circle. Got that? No, straight line passing through a circle, touching at only one point on the circle. So, keeping that in mind, shall we try to draw some tangents from anywhere? So, got one, touching at only one point, right? Got one, touching at only one point, right? These are all tangents. I can have so many tangents. This is one. Okay, this one that doesn't even touch, isn't it? Oh, okay. You might be thinking, sir, yeah, that one that doesn't touch also. Tangent. Can you try to draw tangents again? Be with me. Tangents. So I hope you've understood the concept with this, no? What is a tangent? A tangent is just a straight line that is passing through a circle, but it touches at only one point. Got that? Touches at only, oh, this circle is going that side, no? Center, touching at only one point. Alright? And this point, so got that, no? Once again, a tangent is nothing but a straight line passing through a circle, touching at only one point. Now, the condition is, some of the terms is the point where the tangent touches the circle on the circumference, that is called point of contact. Okay, that is called as the point of contact. Alright, point of contact. Done? Chalo. Point of contact. So let's not forget that term. Okay, point of contact means the point where the tangent touches the circle. Now, quickly, I want you to draw a circle. Quickly, roughly. It's okay. Doesn't matter. Don't use compass and all, nothing else. It's alright. Just quickly, just draw a tangent. A circle, sorry. Done? We draw a circle if you want to be actively involved. Okay, now what I want you to do is, my activity will be, you will draw two tangents. Okay, you will draw from anywhere on the circle, but you will draw two tangents. All right, but the condition here now will be, those two tangents that you draw to the circle should be parallel. Okay, should be parallel. All right, so with that condition, you try to see how many parallel tangents can you draw. Two circles, two tangents parallel to each other. Quickly. So yeah, I think some of you, that doesn't take much time, no? Just quickly. Parallel tangents, no? Parallel tangents, parallel tangents, parallel tangents. So chalo, I'll just do parallel tangent. So maybe, okay, this is one tangent that I draw. So for drawing a parallel tangent, I'll have to draw the first tangent first, anywhere, no? Then, okay, I'll draw another tangent here. Bas. So these are parallel tangents. Right, parallel tangents. Bear with me if the diagram is not exactly looking like parallel, okay? Because from the board, standing is like very difficult, no? Okay. Does it look okay now? Yeah. Parallel tangents. Can you draw another? I mean, like, we cannot, isn't it? Because we can have only two parallel tangents, right? So if you have drawn, you can like, this will be a rough figure only, no? So if you're not using compass and drawing proper circles. But anyway, doesn't matter, approximate figures only we will do. Okay, so but I want you to be actively involved. Alright, now the condition is, so there can be a question, how many parallel tangents can we draw to a circle? So we can have only two parallel tangents, right? We can have only two parallel tangents that we can draw to a circle. Next activity will be, mark the points of contact. Okay, mark the points of contact. I'm telling you again, if we have not used the compass and if you have not constructed, then you will be getting approximate figures only. So later on after this video, you can try to draw with compass and then try to draw proper figures. You will get the perfect values. Now the second activity that I want you to do is on the same figure, try to connect the two dots, the 2 points of contact of the parallel tangents that you have drawn. Chalo. So what you will see is, if you try to join, you will see that that line will also pass through the center. I'm telling you again, like maybe your circle may not be perfect, no, maybe your tangents may not be exactly parallel, so that time okay, it may not exactly pass through the center, but as per proper diagrams, maybe after this video you can just draw proper circles, proper tangents. You will see that this line will always pass through the center. So with that we get one theorem. Yeah, we can consider that as a theorem also, that the line joining two parallel tangents will always pass through the center, which will be the straight line passing through the center, which becomes the diameter. Alright? Okay, so that activity is done. Now the next activity that I want you to do now is, so before that, let me ask you a question that is like, okay, now since we already know what are tangents, if I ask you, how many tangents can you draw to a circle? How many tangents can you draw to a circle? What will be your answer for that? Your answer will be 1, 2. I can draw infinitely many tangents, isn't it? Because I can, as we have seen, we can just draw tangents, 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 tangents. Remember, should touch only 1 point. So we can draw infinitely many tangents to a circle from anywhere to that circle. Alright, now my next activity will be, ready for the next activity? Now my next activity will be, draw a circle, quickly, draw a circle, and once that circle is done, mark a point P anywhere outside. Mark a point P anywhere outside. Alright, now from that point P, I want you to draw as many tangents as possible to this circle. Okay, we are already learning many theorems by now, okay, but definitely in the last I'll summarize all the theorems. I want you to draw as many tangents as you possibly can from the point P to this circle. Done? I believe that you were able to draw only 2 tangents. If you have done it accurately and honestly, I am sure that you were able to draw only 2 tangents. Okay, you were able to draw only two tangents from one fixed point. Previously I was telling you, we can draw infinitely many tangents to a circle. Yes, definitely, because there from that point it was not mentioned from anywhere. So that's why we could draw from anywhere infinitely many tangents. But this time if we keep the point fixed at P, that time what will happen is you can draw only two tangents to a particular circle. Okay, another activity again following up the same theorem. That is, now what I want you to do is pick up your scale. Okay, pick up your scale and then approximately again. Okay, as I said, we are not geometrically constructing the figure here. What I want you to do is pick up your scale and then try to measure this. Let's name this as A, let's name this as P. PA, measure it roughly. You might have got right. PB, next you measure PB. Again, measure it roughly. Now you will see that I'll talk in approximately only now, because as I say, as I keep on repeating, we have not geometrically constructed. I believe even you have not geometrically constructed the figure. You will find that PA will be approximately equal to PB. Actually, as per the theorem, it should be PA is always equal to PB. That is let me summarize that theorem. That is, from an external point, there can be only two tangents that can be drawn to a circle, and the length of those two tangents to the circle till the point of contact will be also equal in length. Alright, so that theorem is also done. Now the final activity. Draw a circle quickly. Draw a circle quickly. Please draw a circle. Are you done? Have you drawn a circle? Chalo. Then, now what I want you to do is draw a tangent anywhere. Draw a tangent anywhere. Draw a tangent anywhere. Okay. For me, I'll draw here. Okay. Draw a tangent. Mark the point of contact. Got it? Mark the point of contact. Now, from the center, I want you to join the center and the point of contact. Center and the point of contact. Join. The tangent, center, point of contact. Let's name that as P. Okay, done. Now, if you have your protractor around you, if you don't have, maybe after this video you can just confirm and you can just check. Okay, if you have your protractor, remember again I repeat, for geometrically properly constructed materials. Now, just roughly 85, 86, 87, 90, 95 chalega approximately. For now, I mean, okay. If you have your protractor now, if you've drawn the tangent properly, join the center and its point of contact. If you measure this angle, you will see that this angle is 90 degree. 90 degree. Isn't it? Approximately. Right? That means that comes up to one more universal fact, that is, a tangent will always be perpendicular to the radius. A tangent will always be perpendicular to the radius through the point of contact. Okay, a tangent will always be perpendicular to the radius through the point of contact. So these are some of the theorems that we are going to be needing in class 10. If I have missed out some theorems, definitely in the next video I will update you with those theorems also. But these are some of the theorems. So what have we learned so far today? Let's do a quick recap. Circles, radius, diameters, chords. Okay, that is done. Then what we learn about tangents, straight line passing through a center. Passing through just one point on the circle. Fine. Second one was we can draw infinitely many tangents to a circle. Chalo. Third one was, okay, from an external point we can only draw two tangents. Fine. Another property was those two tangents are supposed to be equal in length. Chalo. That is also done. Last one that we learned is, if you draw a tangent, the point of contact center, you join the angle made by the tangent and the radius at the point of contact will be a right angle triangle. Right angle that is going to be 90 degree. Got that? Okay, so that sums up. Okay, that sums up what we are going to study in class 10 standard in the topic called circles. So all your questions will be now basically involved with these theorems only. Alright, we'll be basically involved in these theorems only, nothing more than this. Alright, so definitely I'll be looking forward to the next video where we will be solving some questions, almost all the questions of the NCERT textbooks. Okay, all right, but before we go, just one more topic I just remembered now only, that is we have a term called second also. Okay, we have a term called second. So what is a second? A second is, I'll just make it quickly, a second is nothing but a straight line tangent to one point. No? Second passing at 2 points, 1 and 2. A straight line passing through a circle touching at 2 points. So that was a second. Okay, tangent at only 1 point, second means touching the circle at 2 points. So alright then, hopefully I believe that you have liked this video. If you have liked this video, please hit the like button and please do subscribe to my channel so that you'll get regular notifications, and I'll be looking forward to the next video. Please do look forward to it so that you'll get the notifications if you subscribe, where we will be solving some exercises. I'm going to make it very simple for you because it is simple. Not that I will be making it simple, the topic itself is very simple and very interesting. Alright then, thank you. Signing off from Sen Tutorials. Hopefully we will meet again.